Hey everyone, today we are looking at section 8.2, which is trig ratios. This is going to be one of the most important lessons that we do in geometry because it is something that will carry on into Algebra 2, pre-calc, and some calculus. So what we're looking at here is when we talked about special right triangles, and we talked about those 45, 45, 90 triangles and the 30, 60, 90 triangles. We said that if we had a triangle, a right triangle that had a 30-degree angle, we knew that the relationship between the shortest leg and the hypotenuse was that the hypotenuse was twice the length of the short leg. All right, that was our relationship. So because the angle measured 30 degrees, I knew that the short leg and the hypotenuse had that ratio where the short leg was half the hypotenuse or the hypotenuse was double the short leg. Same thing was true with the 45, 45. Because I knew that one of the acute angles in that right triangle was 45 degrees, I knew that in order to find the length of the hypotenuse, I just took the length of the leg and multiplied it by the square root of 2. It was those angle measures that gave us the relationship between two sides of the triangle. So what we're looking at here with the trig ratios is now whenever we have an angle that's not 30, 60, or it's not 45 in our right triangles, we can use trig ratios to find the relationships between the other pairs of sides. So what we are looking at here is every time I say, and it's really important that you know that when you are looking at your triangles, the first thing is you've got to label them. That is such a big part of what we're doing. So the way we're going to label these triangles when they are not a special right triangle is if I look here at my trig ratios, the sine of angle A is going to be the opposite leg over the hypotenuse. So the hypotenuse is still the hypotenuse no matter what kind of right triangle we're dealing with. So like if I look at this right triangle over here, my hypotenuse is still C. That doesn't change, okay? But now if I look at my ratios, instead of having long leg or short leg, I have opposite leg and adjacent leg. So what I'm going to look at is if I look here at the sine of angle A, each one of these are coming from angle A. So I'm going to take angle A and I'm just kind of going to color it in here for just a second. So now I want to figure out which leg is my adjacent leg and which leg is the opposite leg from angle A. So the way that I do that is I'm going to say, okay, which leg, A or B, actually touches angle A, okay? Because adjacent means next to. So the leg that is next to this angle, it touches this angle, is my adjacent leg. So side B is my adjacent side because it touches angle A. Side A is across from angle A, so it is opposite it. So I'm going to use O and A as the labels for my opposite leg and my adjacent leg in this chapter, or in this section. All right, so one way that we can help remember what the trig ratios are, and I'm actually going to pop back here for just a second, our sine will be the length of our opposite leg over the hypotenuse. So it'll be this side, which is A, over C. Cosine is our adjacent leg over the hypotenuse, and our tangent is going to be opposite over adjacent. So one thing that's used frequently to help you remember those trig relationships and those ratios is that the phrase Sohcahtoa. Okay, Sohcahtoa is widely used throughout the math community to help you remember those trig ratios. So when we look here, S is going to stand for sine, O is going to stand for opposite, and H is going to stand for hypotenuse. And you will see me write this as so, because sine is opposite over hypotenuse. That's the relationship between the legs. And again, if this doesn't make a whole lot of sense just yet, don't stress over that. We're going to get an example here in just a second. Okay? With the ca, C stands for cosine, A stands for adjacent, and again, H stands for hypotenuse. And again, you will see me write it this way. So I'll have so, ka, and then we look at toa. In TOA, T stands for tangent, O stands for opposite, and A is again adjacent. And you'll see me write it like this. Okay, so Sohcahtoa is very, very common in math circles. Please use that to help you remember what those trig ratios are. If you can remember Sohcahtoa, you will remember how the setup goes. Let's take a look at what I mean. So what I'm going to do is I'm going to kind of write Sohcahtoa up here in the corner so that I can use it to kind of reference back. All right, now I want to write the trig ratios. First things first, a ratio, remember, is just a fraction. Okay, so when I ask you for a ratio, your answer should be a fraction. Okay, so let's take a look. For A and B, I want the sine of angle R and the cosine of angle R. So what I'm going to do is I'm going to come over here and I'm going to fill in angle R. And I'm going to set this up. So now, again, the first thing I want you to do in every single triangle is label your sides. So the 13 is my hypotenuse. That doesn't change. In any right triangle, it's always H. So now between the 12 and the 5, I want to see, okay, which one touches angle R? And that's my 5. 5 is going to touch angle R, so that is my adjacent side. 12 is across from it, so it is my opposite side. So now, if I'm looking at the sine of angle R, sine is the so part, so it is opposite over hypotenuse. So the sine of angle R, well, the opposite side is 12, so that's going to be in my numerator. The hypotenuse is 13, so that is in my denominator. Guys, that is a fraction. It is fully reduced. That is your answer. Your trig ratio for the sine of angle R is 12 over 13. Now, let's say it was like 12 over 14. Then we would have to reduce that to 6 over 7. So remember that your fraction should always be all the way reduced if you're writing a ratio. All right, cosine, we're going to look at the same thing. That's the so its cosine is adjacent over hypotenuse. So my side that is adjacent to angle R is 5. And again, my hypotenuse is 13. So what I'm going to do here is, because if we look at C, now I want the tangent of angle S. So I am going to kind of copy this triangle over. And I'm going to relabel it in terms of S, because now I'm looking here at this angle. Okay, so 13 is still my hypotenuse. That doesn't change. But now 12 is going to touch angle S. This side here, ST, touches angle S. So now this becomes my adjacent side. 5 becomes my opposite side. So if you want to sketch that off over to, on the right-hand side of your notes, that would be a good place for this. But this is where our second set of sides is going to lay, okay? So tangent is TOA, but again, since we're going from tangent of S, my opposite side is now 5, and my adjacent side is 12. If I wanted to do the tangent of angle R, it would be the reverse. It would be 12 over 5. Please make sure that if you ever do have a fraction, such as 12 over 5, that you are leaving that as an improper fraction. Leave it as 12 over 5. Do not try and convert it to a mixed number. Please no. Okay, leave things as a ratio, which is a fraction. All right? So let's go ahead, and I want you guys to try this one on your own. Remember, first thing I want you to do is to label all your sides. Okay, color in that angle that you're basing everything off of, and then setting up these ratios. So go ahead and pause the video now and get this piece done. All right, go ahead and check your answers. So remember, we're looking at our Sohcahtoa. All right, if I looked at it this way, okay, if I'm doing the cosine of angle A, that means 7 is my opposite side, 24 is my adjacent side. and then my hypotenuse is 25. So opposite over adjacent, adjacent over hypotenuse is 24 over 25. For B and C, we're going from angle B. So now the 7 is my adjacent side and 24 is the side that is opposite. Again, 25 is still the hypotenuse. So for my tangent, opposite over adjacent is going to be 24 over 7. And then my sine will be opposite over hypotenuse, so 24 over 25. One thing that I kind of want to highlight here, look at these two. The cosine of angle A and the sine of angle B have the same ratio. Okay, that will always be true in your between your two acute angles. Please know we're not going to be setting up any trig ratios from your right angle. So I'm not going to ever ask you for the cosine like of angle C in this problem. It'll always either be from A or from B. But the cosine of one angle is always going to be the same as the sine from the other because the opposite and adjacent sides switch. All right? So what I want you to do here, what we're looking at with this piece is your calculator. Okay, this is one of the biggest pieces that you really need to take away from this is how to put things in your calculator. So if you have a single line calculator, that means you are only looking at one number at a time, and every time you put in another number, what's in your window changes. Okay, a single line calculator works backwards. So you would type in 76 and then you're going to hit the cosine button. And you should get 0.2419. Okay, so please, whichever calculator you have, please check to make sure that you get this. If you have a two-line calculator where you can see the entire thing that you're putting in all at once, then you hit equal sign and then your answer comes up on the line below that. Then you can just type in cosine, hit that COS button, type in 76 and hit equals. All right. But know that we are using the single calculators for our FSA, or the single line calculators for our FSA. So if you Google a scientific calculator, look for one that has a single line, or most of the phone calculators are also single lines. If you turn your iPhone to the side, it'll work like a single line and you'll get those trig functions. Okay. I also want you to try the sine of 8. So you should be getting 0.1392 when we round it off to the nearest 10,000th. Okay. And then also do the tangent of 82. Again, this is just getting you practice putting those numbers into the calculator. One thing that is super important is that if you are trying and you're like, I'm not understanding why I'm not getting these numbers, you need to check your calculator. Because the most important thing here is that your calculator is in degrees. If your calculator says D or DEG somewhere in the top of the window, or if it doesn't say anything at all, chances are you are more than fine and you're in degrees and you should be getting this information. But if you see an RAD or an R or a G or a GRAD, your calculator is in radians or gradients. If my calculator is in radians and I try to do the cosine of 76, I'm going to get 0.8 something something, okay? So this would become 0.8. So it is really important that your calculators are in degrees, because if you look, 76 is in degrees. We want that to match. Radians and gradients are other ways of measuring angles. We're not ever going to get into gradients, and we will talk about radians later in the year. But it's really, really important that if your angle measure is given in degrees, that your calculator is given in degrees, because you can do your entire assignment correctly. And if you are putting things into the calculator with the wrong angle measurement, then you will get every answer incorrect. So you just need to make sure first thing you do that you check that your calculator is in degrees. All right, so let's take a look at solving some equations here. All right, what I'm going to do is I want to find each side length and round the answer to the nearest hundredth. So for A, I want to find the length of MP. So I am going to put an X here on MP because that's the side I'm trying to find. Notice that they give us that this angle measure here is 20 degrees. So this is the angle measure that I'm going to go from. Now, do we know that this angle is 70 degrees? Absolutely. It's just 90 minus 20. But every math piece that you do is a chance for a possible mistake. So you always want to go from the angle that is given to you, because we all make goofy errors now and then. It happens to the best of us. So you don't want to take the chance of making a silly math error and then getting your whole problem wrong because you made a silly math error. If for any reason they gave you both the 20 and the 70, just pick one. It really won't matter. Just pick an angle to go from and color it in, and then just pretend like the other angle is not there. So what we're going to do, first thing, every time, I've been saying it, you've got to label your triangle. You have to label your triangle. You have to label your triangle. Okay? But what we're going to do here is we're going to only label the sides we're using. Okay, again, we are going to only label the sides we are using. So they gave me 8.7. 8.7 is my hypotenuse. All right, I'm finding side MP. This is opposite angle N because it's not touching. So I'm going to label that as my opposite side. I'm not doing anything with side MN. I'm not finding it. It's not given to me. So I am going to ignore that side completely. And here's why. When I come over here, and please make sure that if you are watching this at home that you are writing this kind of over somewhere on that back side of your notes, so you have it on the front and the back of your notes. I'm going to write my Sohcahtoa. Look at what's happening here. I have an O and I have an H. Well, I can come over here and see, well, which trig function uses O and H? And I see that it's my sine. So if you only label the two sides you're using, your trig function, it pops out a lot easier at you of which one you're trying to use. Okay, if you label all three sides, it's a little more difficult. I mean, you can still do it, but it doesn't jump out like, oh, O and H, oh, O and H. Okay, so make sure you're only labeling the sides that you're using. So I'm using sine, so I'm going to set this up as the sine of my angle. So I'm going to do the sine of 20 is equal to my opposite side over my hypotenuse. So my opposite side is x, my hypotenuse is 8.7. Now, before we get started in this, I want you to think about what we just did by putting all those trig ratios in the calculator. Okay, the sine of 20 is one number. It cannot be broken apart. You cannot divide both sides by 20 or divide both sides by sine and leave the 20 hanging out by itself. That is not how these trig functions work. The sine of 20 will stay together at all times. Okay, so anytime you have a number here, they stay together. Now, in the next lesson, we're going to put an x here and figure out how we can break that apart to get to it, but you have to use a different function. So when you have the sine of 20, that stays together. So now the question is, well, I'm going to look at my equation here. Well, how do I get x by itself? All right, so I'm going to multiply both sides by 8.7. All right, so I'm going to get 8.7 times the sine of 20 is equal to x. Now, in your calculator, you are going to type in 20, hit the sine button, and do times 8.7. Again, that is if you have those single line calculators. If you're on the double line, you can just type this in exactly as you read it and hit enter. So you should get 2.98 when we round it. Centimeters is going to be your x. Make sure you are including your units of measure in your answers. All right, so questions on that, make sure you're making note of it and writing it down so that way you can ask me in class. All right, let's do another one, okay? We want to find the length of AB, so I'm going to put an X on AB. All right, so when I look at this, again, I'm given the 41-degree angle, so I'm going to kind of color in this corner. And I want to label my triangle. All right, X, this side AB, is going to touch the angle 41, so it is my adjacent side. 6.1 is across from angle A, so it is my opposite side. So again, I'm looking at opposite and adjacent, and that is going to be my tangent. So again, that is why we only label those two sides. So from here, I'm going to set up the tangent of my angle, so the tangent of 41 equals opposite side, which is 6.1, over the adjacent side, which is x. Now, when we were over here with part A, to get 8.7 out of the denominator, we multiplied both sides by 8.7. Same thing needs to happen over here. I need to get this x out of the denominator. So I'm going to multiply both sides by x. So I am going to get that x times the tangent of 41 is equal to 6.1. Now to get x by itself, I can divide both sides by the tangent of 41. So I am going to get that x is equal to 6.1 divided by the tangent of 41. Okay, again, double line calculators, you just type things in the way they look. 6.1 divided by tangent 41, hit equals. But with the single line calculators, which is what, again, I really want you guys to be using right now, is you're going to type in 6.1, hit divided by, then you're going to type in 41, hit the tangent button, and then most importantly, you need to hit the equal sign when you're done, because as soon as you type 41 and hit the tangent button, the number changes, but what you're looking at is the tangent of 41. If you hit equals, then that finishes your problem. You should get 7.02 inches. Now, let me show you guys a little bit of something here. When we were talking in chapter 7 about the ratios and the proportions and all of that, those relationships, I could have A over B equals C over D. And a lot of you guys were telling me when we were doing stuff like, hey, I set this up differently, but I still got the right answer. Well, remember, as long as your diagonals are the same, then your proportion is equivalent to mine. So I could switch the diagonals, D over B equals C over A, and I'm still going to end up with the same equation, right? I can go back and forth between these two. It's okay. All I did was flip-flop this diagonal. Well, let me show you a little something here. If I have the tangent of 41 and I put it over 1 and set that equal to 6.1 over x, well, look what I have. I have a proportion. Well, what did I do here? I switched the diagonal. So when I get this, can I switch the diagonal? Absolutely. I can do x over 1 equals 6.1 over the tangent of 41. Gives me the same thing. So now you can go from this piece straight to this piece. And I'll do the next one like that. But I just want to show you why you can do it and where it comes from. If not, look guys, just multiply both sides by x, then divide by your trig function. It'll be fine. But it's, a little weird to say it, but you know what? I'm okay with being a little weird. And it's, it sounds silly, but listen, when your variable is in the denominator, you're going to divide by your trig functions. This D sounds go together. Again, I know it sounds stupid, but I'm totally cool with it. I'll own it as long as it works. Variables in the denominator, you divide by your trig function. Those D sounds go together. So let's take a look at this next one. All right, again, I want to find YZ, so I'm going to label that as X, and then I'm going to label the pieces I know, okay? I'm given angle Z, X is my hypotenuse, and then 12.6 touches angle Z, so it is adjacent. A and H is my cosine, okay? So I'm going to set up the cosine of 38 equals my adjacent side, which is 12.6, over my hypotenuse, which is x. The variable's in the denominator, so I'm going to divide by my trig function. I can switch these because of the proportion. So I can go right to x is equal to 12.6 over the cosine of 38, which personally I like to do a lot better without having to multiply both sides by x and then divide by the cosine of 38. But if that doesn't make sense to you, then do the other way, okay? Do all the steps out. So then again, in your calculator, you're going to do 12.6 divided by 38 cosine and hit equals. you should get 15.99 when it is rounded. Now, it is not the case with this problem, but a side note that we need to clarify here is that let's pretend my answer was 15.998 and I needed to round the nearest hundredths place like I'm doing right now. That 8 would round the 9 up, which would round that 9 up, which would send me to 16. But here's the deal, guys. That 16 was rounded. So you cannot leave it as 16. You need to put 0.00 because what this tells me is that you rounded this to a 16. If you just write 16, that is an exact answer. Okay, 16.00 has been rounded. All right, so if you do a trig function and you get a number right on the money, right exactly 16, then you write your answer as 16, no matter what you're rounding to, because it was exactly 16. But if you get 15.998, then you need to write down 16.00, because that tells me that you didn't get exactly 16, you got a number that rounded to 16. So it is important that you know the difference between that, because if you have something that you are supposed to put to the nearest tenth or to the nearest hundredth, and it rounds to a 0.0, and you don't have that 0, you will get points taken off. Okay, so you need to make sure that you have that decimal accuracy. All right, so what I want you to do is to go ahead and pause your video and give these a shot. Okay, try these on your own, and then we'll put up the answers in just a second. So go ahead and go through this. All right, go ahead and check your answers. Pay attention. If you're getting different answers, make sure you're using the same trig function that I did. Okay? If you're using a different trig function and you're like, but I thought that was sine or I thought that was cosine, okay? Check your labeling. Make sure, hey, this side here is across from the from the right angle. So this 9.5 is the hypotenuse, not the adjacent side, or things like that. So just make sure you're paying attention to if you're getting different answers. Check your labeling first, see if you labeled correctly. Check your trig function, see if you picked the correct trig function. Then from there, check your work. If you did everything else right, check your calculator, make sure you're in degrees. Okay, if you have any questions, make sure you write that down and let me know in class. Again, guys, this is super important. You need to have this material well in hand. So again, any questions, please, please, please let me know. Have a wonderful day, guys, and I will see you in class.